There we go. Music, villainy, and larceny? What else shall we do? Welcome to day 16. I said 14 yesterday. It was actually day 15 yesterday. So that video is wrong. The title is right. It's updated. And the description is too. But I say 14 in the video. And I was a big bad and did it wrong. So, quieter on the music. Thank you. So this one is going to be another machine learning one. And I can already tell you we're not going to be able to do the final step. Because it involves solving a CAPTCHA. And while we'll be able to have the AI model do it for us, that's kind of the point of the task. We won't be able to actually do that in real time. So while we will be able to do most of this task, provided I can get access to the machine, which is another thing I'll cover in just a minute here, we will not be able to do the final step. It doesn't matter. I already have the flag, and I think I have another idea on how to get it, which will require a little bit more hacking than the average Joe would have to do. But we'll get to that when we get to it. I thought this would be an interesting time because it is all about OCR and basically making an AI or a machine learning model solve CAPTCHAs. I think it'd be a good video to explain how I do some of the things I do, and that's why I'm actually going to do what I call pre-hacking, where I have to make sure the task is equal for everyone first. I'm going to actually do that in this video because it's going to be mostly me reading text for the rest. It's going to be like a lot of theory for machine learning again, so I wanted to give it a little bit more interaction by me actually showing off what it is I do on like a daily basis. I don't have NVDA's speech viewer up currently because, again, there's going to be command line interactions and it's going to cover it up. So I will do my best to narrate what I'm doing as I'm doing it and have the Screenreader speak as well. Currently it's off, but that's fine. I got a question about this last night in the comments. I'll just explain it here as well. Basically, I use both a Braille display and a screen reader. The screen reader powers the Braille display, so in that sense, the Braille display gets its output from the screen reader, and therefore I can read it using my fingers rather than my ears, which is really helpful when I have to read stuff out loud, which I have to do a lot with these tasks. So generally, the screen reader doesn't speak unless I want it to, and I want it to usually when I want to get something done fast. It's just a lot faster to hear speech than it is to read Braille. But if I need to be accurate or if I need to do something in real time, it's just easier to do it with Braille, which is what I tend to do when I read you these task descriptions. Another thing, there's a couple of things I do to make things that are inaccessible more accessible. One is OCR, actually very similar to what this task is about, except it's built into Windows, and NVDA, the screen reader I use, hooks into that and then makes an image of the screen and gets the text from it, which it then makes navigable, and then you are able to essentially find one of the words in that image that it's taken, and NVDA is aware of the coordinates where that is on the screen, so you can tell the mouse to go there and click, which is how I click certain things in, for example, virtual machines, where when you are in a virtual machine, the screen reader doesn't have access to that machine. It's pretty much an opaque black box for it, because it's its own OS, it's its own screen, its own OS, and its own sort of set of UI controls that the screen reader doesn't have access to. So what I'm going to be doing is actually very similar to the AI thing that we have for today. We have we have a machine that we need to do. We have a machine that we need to essentially is this the right one? I think this is still Edge. Yeah, this is the wrong one. We have a model that's going to solve CAPTCHAs for us. That's going to be what the AI does, and I'm going to be using a very similar technique to first get the machine sort of usable for us. So that's kind of amusing. That's actually really serendipitous, I guess is a good term for it. So let me start the machine. That's going to take a few minutes while I set up here. Here we go. Another thing I do, you've seen me do this a few times, is use the AI to ask questions about the currently visible screen. That's actually gotten me through some rough scrapes through these last 16 days now. It's actually been super helpful to glean answers in YouTube videos, for example. I used to hate video trainings because often, like when you have to code along with a person in a video, you couldn't see as a blind person what the code in the video was. That is now a little easier with AI. It's still annoying as heck to do, but it's at least possible now, so that's definitely good. But yeah, I think with all that aside, I'll just start reading all the content here. We will at some point stop to pre-hack the virtual machine. once it's up. It's not up yet. Now we have to wait for it to... Wait, what? It didn't start starting. Oh, no, it did. Just didn't... The button didn't switch to being disabled. Strange. Actually, we'll do the pre-hacking first, because we're going to be like having access in like a minute or so. So what I'm going to have to do here, I'll just talk you through it. I'm going to have to enable SSH on this machine, which essentially involves me copying my public key into that machine's authorized keys file. There's already one present, usually just because I can't see what I'm doing in those files. I just remove the one that's there and put my own in there. Just I make a new authorized keys file and paste my stuff in there, and then usually that is enough to get me SSH access, which makes the whole thing a whole lot more doable. So that's what I'm currently working on. That machine is loading, and I'm grabbing the my key. I can paste it in a minute. Just waiting for it to load. There it goes. So because it has the .pub extension, my Windows keeps thinking it's a publisher file. I didn't even know publisher was still being used, but apparently it is still very much alive. I'll just open this in Notepad++ real quick and grab it. Once my Screenreader will start speaking, I will turn this down a bit because it is a bit on the loud side. There it goes. Here's the RSA key. So I'm going to turn the music down a bit, and then we can start this stuff. There. All right, so machine's done. In 5 seconds, that is. 3, 2, 1, and there it goes. So we have a desktop. This is one that actually, I actually chose this one to do this with rather than the previous one because this one's a lot easier to do. Yesterday's one took me a lot more doing to actually get accessible, and it would have taken like an hour longer to actually do the video. This one is actually relatively simple. I've done this one this setup that we have here, I've done it a few times already. So we can just do it quickly, and there's no NVDA panel in the way either to make this even harder than it needs to be. So let's just do it real quick. What I'll have to do is turn the speech on.
Speech mode talk.
And I will have to OCR the panel that holds the remote machine. So I'll do that, and we get this particular result.
Recognizing result document. Applications. Roots home. Terminal. Tools. Additional tool. Roots home. Applications.
Roots home. We're root on this machine. Interesting.
Roots terminal. Tools. Additional to. Places system. File. Sat December 16th, 2054. Attackbox IP:10 Sat December 16th.
So it thinks it's 16th of December. Interesting.
Attackbox IP:10.10.32.173. Terminal. Edit. View. Search. Terminal 001. This machine can access other machines you deploy on TryHackMe. Please keep TN mind the following. 1, 2, 3. 1 text automatic usage and is secure. Do not store 1. Tools 2. Web 3. 4.
Yeah, okay. Blah, 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 blah. Basically, the first thing we need is the terminal. So I'm going to do that again. And it says terminal here. I'm going to route my mouse to that particular bit of text. And that should be here. And I'm going to double click to make the terminal hopefully appear. Now we have to dismiss the OCR result and make a new one to see if it actually worked. We're not going to be doing this every time because I kind of know what's happening these days, but let's see. So we are currently root on this particular terminal. I actually want to be in Ubuntu's shell, so we're going to have to move directories first and foremost. cd/home/Ubuntu. Let's see if that works. I'm pretty sure root can just edit those anyway. So did we do it? Are we in Ubuntu's thing right now?
File edit root tp10 attackbox on root tp10-10-32-173 attack ck TryHackMe is ill have time left. Internet and Mabio. Tor sensitive file. Do you think something's missing? Let us know. Press enter key to close. Supported TryHackMe -4. Ill news star Google.
Press enter key to close. Okay. Can I just click that and get rid of it?
Supported TryHackMe.com. Press enter key to.
Oh, evidently not. Okay, well, doesn't really matter. What we do next is we do cd.ssh. We do rm authorized _keys. We do nano authorized keys. Then we paste. Then we do Control X, Y, enter. With a little bit of luck, we should now have SSH access through the Ubuntu user. Let's see if that's the case.
Tech folder view list 3C Windows system.
SSH Ubuntu at the IP I just copied.
The authenticity of
This authenticity cannot be established. That's
warning,
cool.
permanently added 10.10.3.
And it's asking for a password. Oh, that's a new one. Okay. That is a new one. That means we need to do one more thing. Interesting.
TryHackMe advent of cyber
We'll need to change Ubuntu's password because we don't have it.
10.10.32 answer format 7 star 10 button open frame edit multi.
Password Ubuntu. The password is going to be password. Password. Now let's try if we can actually use that. Unless I made a mistake, in which case I'd have to go OCR to see what I broke. The password should be password.
System information.
It is. We are in. Very nice. Okay, so we just made this box accessible. In a way that I really shouldn't have to do, but I figured this would be educational for anyone to watch how I just did that. Not sure how much was visible on the actual screen because I have no idea if this is scrolled into view or not, but that is what I have had to do for several boxes. Just turn SSH on, or if it's already on, give the user that we have access to SSH, which usually involves either pasting my public key in there or doing that and also changing the password. Which, fortunately, because a lot of these VMs usually get like snapshotted when sudo is still running, like as in the sudo timer is still running. I don't need the password for root to get root. And at that point, if I have root, I can change the password for the user and then just have it SSH accessible, which is what I just did. So we're good for the moment. We have access. We can actually run commands on this. Otherwise, we would not be able to. Which means that now I get to do the arduous procedure of reading yet another machine learning theory block to you all. This time about convolutional networks. So here we go. Let me see. Task number, what is it? 22. Day 16. Machine learning can't capture this machine. Alright. Start machine. This machine is already started. This story. Task banner for day 16. We don't get to know what's on there. McGreedy has locked McSkitty out of his ELF TM HQ admin panel by changing the password ! To make it harder for McSkitty to perform a hackback, McGreedy has altered the admin panel login so that it uses a CAPTCHA to prevent automated attacks. A CAPTCHA is a small test, like providing the numbers in an image, that need to be performed to ensure that you are a human. They are also very inaccessible a lot of the time. Just a note from the editor here. This means McSkitty can't perform a brute force attack. Or does it? After the great success of using machine learning to detect defective toys and phishing emails, McSkitty is looking to you to help him build a custom brute force script that will make use of machine learning to solve the CAPTCHA and continue with the brute force attack. There is, however, a bit of irony in having a machine solve a challenge specifically designed to tell humans apart from computers. Learning objectives. Complex neural network structures. How does a convolutional neural network function? Using neural networks for optical character recognition, OCR. That's the thing I told you about earlier. Integrating neural networks into red team tooling. Accessing the machine. Before moving forward, review the questions in the connection card shown below. There's a thing that just says, start the target machine. A split screen view iframe is available for the target. We will not be needing our attack machine today. That's true because everything will be happening on the target machine, which is why it's extra vital for us to have access to that machine in a way that's accessible, which is what we just gleaned from getting that little SSH hack going earlier. Like I said, we're also going to have to hack around the fact that we have to, essentially, when we have the CAPTCHA solving script, it's going to give us a password that we need to enter in order to log into the thing. But we also need to solve the CAPTCHA ourselves, which we cannot do because we're blind people. So we're going to have to find where that website is and see if I can glean the flag from the code. I do have it already filled in case we can for whatever reason, but I want to give it an old college try. To access the machine that you are going to be working on, click on the green Start Machine button located in the top right of this task. After waiting 3 minutes, the VM will open on the right hand side. If you cannot see the machine, press the blue Show split view button at the top of the room. Return to this task. We will be using the machine later. Okay. Well, I guess I will have to add an addendum and then hack the shit out of it to show you can actually access it over a way that's accessible to you. But okay. We've done that. Introduction. In today's task, we'll get our first look at how red teams can use machine learning to help them attack systems. But before we can start attacking the admin portal, we'll need to expand on some of the ML concepts taught in the previous tasks. Let's dive in. Convolutional neural networks. In the previous task, we talked about neural network structures. However, most of these structures were fairly basic in nature. Today we'll cover an interesting structure called a convolutional neural network, or CNN. CNNs are incredible ML structures that have the ability to extract features that can be used to train a neural network. In the previous task, we used the garbage in, garbage out principle of having good to explain the importance of our inputs having good features. This ensures that the output from the neural network is accurate. But what if we could actually have the neural network select the important features itself? This is where CNN comes into play. I didn't know CNN did that. I thought they were just a Canada news network. In essence, CNNs are normal neural feature extraction neural networks that simply have the feature extraction process as part of their network itself. This time, we're not just using maths, but combining it with linear algebra. Algebra. Oh, we say algebra. Algebra. Is it GIF or GIF? Again, we won't dive too deep into the maths here to keep things simple. We can divide our CNN into three main components: feature extraction, fully connected layers, and classification. We've actually already covered the last two components in the previous tasks as a simple neural network structure. So our main focus for today will be on the feature extraction component. Feature extraction. I'm sad to see there's no headings in this task. There was a couple in the previous ones, and I'm pretty sure these are the same creators, so you're slipping, buddy. Anyway, feature extraction. CNNs are often used to classify images. While we can use them with almost any data type, images are the simplest for explaining how the CNN works. This is a CAPTCHA that we are trying to crack. Image that just says single CAPTCHA as alt text. Since we'll be using a CNN to crack CAPTCHAs, let's use a single letter in the CAPTCHA as our image. Single CAPTCHA letter. Doesn't say what letter. We have to guess what letter it is. Image representation. The first question to answer is how does the CNN actually perceive this image? The simplest way for a computer to perceive an image is as a 2D array of pixels. A pixel is the smallest area that can be measured in an image. Together, these pixels are what creates the image. Fair enough. A pixel's value describes the color that you are seeing. There are two popular formats for pixel value. RGB, the pixel is represented by three numbers from 0 to 255. These three numbers describe the intensity of the red, blue, and green color of the pixel. Or grayscale, the pixel is represented by a single number from 0 to 255. 0 means the pixel is fully black, and 255 means the pixel is fully white. Any value in between is a shade of gray. To represent the image as a 2D array, we start at the top left and capture the value of each pixel before moving down. Let's take a look at what that would look like for our CAPTCHA. Alt text with just says Lottie animation. Now that we have our representation of the image, let's take a look at what the CNN will do with the image. Okay? Convolution. There are two steps in the CNN feature extraction process that are performed as many times as needed. The first step is convolution. The math is about to get slightly hectic here, so take a deep breath and let's dive in. He likes that phrase for sure. During the convolution step of the CNN's feature extraction, we want to reduce the size of the input. Images often have several thousand pixels, and while we can train a neural network to consider all of these pixels, it will be incredibly slow without really adding any additional accuracy. Therefore, we perform convolution to summarize the image. To do this, we move a kernel matrix across the entire image, calculating the summary. The kernel matrix is a smaller 2D array that tells us where in the image we are currently creating our summary. This kernel slides across the height and width of the image to create a summary image. Take a look at the animation below. This one doesn't even have Lottie animation. Here we go again. As you can see from the animation, I cannot. We start at the top left of our image, looking at the smaller 3x3 section. We then calculate the summary by multiplying each pixel with the value in the kernel. These kernel values can be set differently for different feature extractions, and we're not limited to a single run. The values of these kernels are usually randomized at the start and then updated as the network is busy training. Okay. We say that each kernel run will create a summary slice. As you can see from the animation, I cannot. By sliding these kernel across the entire image, we can create a smaller summarized slice of our image. There are a couple of reasons why we want to do this. Another list. Number 1, as mentioned before, we can create a neural network that takes each pixel as input, but this would be an incredibly large network without improved accuracy. The summary created by the convolution process still allows us to capture the image's important details without needing all the pixels. If your CNN's accuracy decreases, then we can simply make the kernel smaller to capture more details during the input phase. The term used for this process is sparse interaction, as the final neural network won't directly interact with each pixel. If you would like to learn more, you can read here. Links with the word here in it are a violation of WCAG. No, don't worry, I'm gonna take off my accessibility auditor hat here, but here is a really terrible name for a link. Okay. If we calculate a feature in one location in our image, then that feature should be just as useful as a feature calculated in another location of the image. Making use of the same kernel to determine the summary slice means this condition is met. Okay. If we update the weights in one of our kernels, it will alter the summary for all pixels. This results in something called the property of equivariance to translation. Simply put, if we change the input in a specific way, the output will also get changed in that same way. If you would like to learn more, you can read here. I just read the word here and I don't understand more. I'm sorry. Okay. Silliness aside, we perform this summary creation with several kernels to create several slices that are then sent to the next step of our CNN feature extraction process, which is pooling. The second step performed in the CNN feature extraction process is pooling. Similar to convolution, the pooling step aims to further summarize the data using a statistical method. Let's take another look at our single slice and how a max pooling will provide a summary of the maximum values. Okay. Another animation that we cannot read. It just says Lottie animation. Not sure who Lottie is. Maybe Lottie is the person who made these animations? Well, thanks, Lottie. Appreciate that. As you can see again, for each kernel, we create a summary based on the statistical method. For max pooling, this is finding the maximum value in the pixels. We could also use a different statistical method, such as average pooling. This calculates the average value of the pixels. Oh, you don't say. I thought it might do like the minimums or something. And that is basically it. That's how the CNN determines its own features. Depending on the network structure, this process of convolution and pooling can be repeated multiple times. In the end, we're left with the pooled values of each of our slices. These values now become the inputs for our neural network. Super cool. Fully connected layers. You said we... Oh, hang on here. Just a second here. You said we already covered these two. Why are you going into it again and giving me more stuff to read? I have thoughts about this. Okay, fully connected layers. Now that we have our features, the next stage is really very similar to the basic neural network structure that we have back in the Introduction to Machine Learning task. We'll create a simple neural network that takes inputs, the summary slices from our last polling layer, run them from the hidden layers, then finally provide an output. This is called the fully connected layers portion of the CNN, as this is the part of the neural network where each node is reconnected to all the other nodes in the next layer. Then we get classification. Lastly, we need to talk about the classification portion of the CNN. This is the output layer from the fully connected layers portion. I would be a terrible audiobook narrator. In the previous task, our neural networks only had one output to determine whether or not a toy was defective or whether or not an email was a phishing email. However, to crack CAPTCHAs, a simple binary output won't do, as we need the network to tell us what the character and later the sequence of characters is. Therefore, we'll need an output node for each potential character. Our CAPTCHA example only contains numbers, not letters, so we need an output node for 0 to 9, totaling 10 output nodes. Having multiple output nodes creates a new interesting feature for our neural network. Instead of simply getting one answer now, all 26 outputs will have a decimal value between 0 and 1. What I'm finding about this person doing the task is that he's really inconsistent about details. He just said there were 10 nodes, not 26. 26 would be if there were letters, and there are no letters here. So stick with like one thing. Don't make it even difficulter than it needs to be. Like there's small little details. Like this would have been good to have like one final little edit to make sure that everything actually makes sense. And I think it may have not been done here. We'll then summarize this by taking the highest value as the answer from the network. Okay. However, nothing is stopping us from reviewing the top 5 answers, for instance. This can help us identify areas where our neural network might be having issues. For example, there could be a little confusion between the character of M and the N, as they look fairly similar. Reviewing the output from the top 5 nodes will show us that this might be a problem. While we may not be able to solve this confusion directly, we could actually use this to our advantage and increase our brute force accuracy. We can do this by simply discarding the CAPTCHA if it has an M or an N and requesting another to avoid the problem entirely. I guess you could. Alright, training our CNN. So the majority of this stuff has already been done for us, and it's going to be a little bit tricky for me to figure out where we actually start taking the wheel. So that might be getting a little bit tricky here. I'm just going to make sure I'm going to quickly flip over to my little shell here and run an ls command to make sure it doesn't disconnect. There we go. Training our CNN. Now that we've covered the basics, let's take a look at what will be required to train and use our own CNN to crack the CAPTCHAs. Please note that the following steps have already been performed for you. The next steps will be to perform in the... The next steps will be to perform in the hosting the model section. Well, there is no hosting the model section. It just at some point start talking about that, but okay. However, understanding how training works is an important aspect, so please follow along and attempt the commands given. So it says don't do the commands, but also do try the commands. Okay. We will be making use of the attention OCR for our CNN model. This CNN structure has a lot more going on, such as LSTMS and sliding windows, but we won't dive deeper into these steps in this instance. The only thing to note is that we have a sliding window, which allows us to read one character at a time instead of having to solve the entire CAPTCHA in one go. We'll be making use of the same steps followed to create CAPTCHA 22, which is a Python pip package that can be used to host a CAPTCHA cracking server. If you're interested in understanding how this works, you can have a read here. But you can try to run all this software yourself. Most of the ML component runs on a very specific version of TensorFlow. Therefore, making use of the VM attached to this task is recommended. In order to crack CAPTCHAs, we will have to go through the following steps. 1. Gather CAPTCHAs so we can create labeled data. 2. Label the CAPTCHAs to use in a supervised learning model. 3. Train our CAPTCHA cracking CNN. 4. Verify and test our CAPTCHA cracking model. 5. Export and host the trained model so we can feed it CAPTCHAs to solve. 6. Create and execute a brute force script that will receive the CAPTCHAs, pass it on to be solved, and then run the brute force attack steps. 1 through 4 are quite taxing, so they have already been completed for you. Okay, so 5 is export and host the trained model is what we need to do. Okay. They've already been performed for you. We'll do a quick recap of what these steps involve before moving on to the hosting the model and cracking some CAPTCHAs. To do this, you have to start the Docker container. In a terminal window, execute the following command. Docker run -d -v/tmp/data :/temp/AOCR/full. I'm going to be running the. I don't think I'm even going to like show the SSH window until it becomes necessary and actually something actually happens that is of note. Permission.
Speech Docker got permission denied while trying to connect to the Docker daemon socket of Unix //var/run/docker.sock host http //%2var%p ubuntu lib 10
Oh, that's because we're not root. Hang on.
Root 10-10-32-107.
Isn't it good that I know a little bit about what I'm doing here so we can dodge around these kinds of problems?
Root 10-10-32.
Oh, that explains why we were root before. Okay, let's go.
Paste Docker run unable to find image /full latest locally. Docker error response from daemon. Full access denied for /full repository does not exist or may require Docker login. Denied. Requested access to the resources denied. See Docker run. Help. Root 10-10-30.
Uh-oh.
Root 10-10-32-173. DOCKERUN.
That's a problem. AOCR/full. That is what it says on the tin.
To find image /full latest. TryHackMe. This will start a Docker command. Docker run dv/tmp/data/temper/. This will need to connect to this container for the next few steps. For this will Docker run dv/tmp Docker run.
Well, so much for that. I don't know. I don't know why it's doing that. It's very strange.
Paste. Unable to find image /full latest locally.
So Docker isn't working. Like this is one reason why I already made sure I had the flag. Apparently, like Docker can be a little like a little bit tricky sometimes, and I'm wondering if that's what's happening here. Maybe it doesn't like me coming in over SSH. Maybe there's something else going on. It's not a huge issue because we don't really need to run any of this to get the stuff to work. Yeah, I don't know why it's not working. I have no idea. This will start a Docker container that has TensorFlow and AOCR already installed for you. You will need to connect to this container for the next few steps. First, you'll need to find the container's ID using the following command. It's just not, it's not working for some reason. Maybe am I in the wrong folder? Is that why? Let's see.
Speech author root 10-10 authorized keys.
I think that's why. I think we're in the wrong folder. Let's go root.
Root 10-10-30. Root 10-10-10. Root 10-10-32-1. Unable to find image address /full. See the Docker error response from daemon. Full X. CTF Builder desktop downloads instructions pictures Postman room scripts Thinkly and drives tools. Root 10 CTF Builder desktop CTF Builder desktop downloads instructions pictures Postman rooms scripts Thinkly and drives tools. Root 10-10-32-1.
Where are we?
DW command not found. Root /root 10-10.
Interesting. I don't know where this Docker container is. Can we find out actually?
TryHackMe advent of cyber.
Where is the command line?
Answer format. When answer format. No answer needed. Edit unavailable. Frame edit multi-line.
Where is the command line window that we're supposed to be in? Let's see. There you go.
Recognizing result document. Edit multi-line.
Oh yeah, we were. Hang on. CD dash. Where are we now?
THM recognize root 10 root TP 10-10 -4 attack box IP :IO 10 root /root CD /home /CD /root TP 10-10
Yeah, we were in here, weren't we? In root. So where is the stupid? Where's the stupid thing?
CTF Builder desktop.
In desktop? In desktop?
Root 10-10-30. Additional tools Mozo main 15. Desktop tools. Root 10-10-30. Additional tools Mozo main tools. Mozo main tools. Mozo tools. Additional. Tools Mozo tools. Root 10-10-32.
Just give me a second while I try to figure this out real quick. Find the Docker container somewhere because it has to be somewhere.
Speed Docker error response from daemon. Full access denied for address /full repository does not exist or may require Docker login. Denied. Requested access to the resources denied.
That is so interesting. I don't think that's meant to be happening. I'm wondering if it's like a... I don't know why this is happening. I really don't know. Can I change the root password?
Enter new Unix password.
Root.
Retype new Unix.
Root.
Password updated.
I'm just going to try to connect as root to this SSH server and see if that works better. I don't think it will, but it's worth a shot. I know there's nothing on the screen right now. I'm just trying to quickly get this done so we don't have that issue. Root.
System information as of Saturday, December 16, 21:24:50 GMT. Paste Docker run DV / unable to find image address /full.
It just doesn't know where that
CTF
is.
Builder desktop downloads instructions pictures. CD download. Oh. Root 10-10. Root 10-10. TC. F builders. Root 10. Classic password 1.zip crack 1.zip crack 2.zip crack 3.zip h4 10.zip hidden message.zip re1.zip strings.zip root 10-10. Root 10. RTNI. Root 10. Empire Starkiller.txt. Root 10-10. Root 10. CTF Builder. CTF desk downloads instruction pictures. Postman. Rooms. Scripts. Thinkly and draw tools. R. Millisec. Root 10. M. 7. AD enumeration AOC3 breaching AD capstone challenge compiled CT. Root 10-10-30. Bottom.
So there's like things for all sorts of different rooms on this VM, but not...
AOC 2023 BP volatility Caldera.
Oh, wait.
S. Caps lock off.
Hang on. I do see an AOC 2023.
COA. AOC 20AOC2023. Space.
Let's see if that's anything. If that has our stuff in it.
023 / root 10. Day 23. Root 10-10-32-173.
Oh, big spoilers. Okay, let's not go in there. Big spoilers for sure. AOC 2023 day 23. I don't think I want to be looking at that just yet. Explore. Just looking if I see anything that has to do with Docker real quick. Parrot, Splunk, Wireshark. No, I don't see it. So I don't know why the Docker container isn't working, but it's fine. We'll figure it out.
Speech mode beeps. Speech mode talk.
Like I said, we would not be able to do the final task anyway. So like once we get to that point, I don't think I would even be able to do the thing because I don't know where the stuff is stored either. It's this machine is way more involved and there's way more stuff on it than the previous ones. So I guess it's a good thing that I grabbed the stuff from the video earlier because I would not be able to find this in a timely manner. I do want to get this video out as soon as possible and not have it take like several hours. So let's just not worry about this right now. and just continue on with what we're meant to be
Appendo
doing, and
selected.
then at that
Try-
point we'll see where we end up. What?
Find error dialog text appendo not found. TryHackMe advent of cyber. Find dialog. Type the text blank. Caps lock on. Caps lock.
Docker run. Whoosh.
Try Docker run.
Okay.
Speed mode
So
off.
this will start a Docker container that has TensorFlow and AOCR already installed for you. You'll just assume that we've done that then, because we can't find it. You will need to connect to this container for the next few steps. First, you'll need to find the container ID using the following command. Docker PS. I'm pretty sure it also tells you when you run the container, like there's a little bit of a string of hexadecimal numbers at the end, like that plays. You can just copy that. Take note of your container's ID and run the following command: docker execute, or just exec -it, then the container ID /bin/bash. This will connect to the container. You may now navigate the following directory for the next few steps. cd/ocr. So that if you were in the container, you'd have to go to /ocr to get in there. For the people who have more luck than me. Gathering training data. In order to train our capture cracking CNN, we first have to create a dataset that can be used for training. Let's take a look at the authentication portal for HQAdmin. Open HQAdmin in a browser window in the virtual machine, and you'll see the following authentication page. Graphic that says website authentication page. Helpful. So what I would normally do is I would go find where that server is hosted, because that means the THM suffix means that it's somewhere on this machine, and I would probably be able to find it if I knew where they stuck it. There's a couple of places I can check. But there is so much stuff on this machine that I would not be able to find, I don't think. There's like so many things on this machine for various different challenges. I don't know why that's the case. But I don't think you really weren't meant to be looking around this particular machine, so I'm going to like limit my interactions with it. As we can see, the authentication portal embeds a CAPTCHA image. We can get the raw image using a terminal window. Curl http aqadmin.thm_2000 of 8000. In the output, you'll see the base 64 encoded version of the CAPTCHA image. We can write a script that will download this image and then prompt us to provide an answer to the CAPTCHA to store in a training dataset. This has already been done for you. You can view the stored data using the following command in the Docker container. ls-alh raw_data/dataset. Creating the training dataset. Okay. Next, we need to create the training dataset in a format that AOCR can use. This requires us to create a simple text file that lists the path to each CAPTCHA and the corresponding and the correct answer. A script was used to create this text file and can be found under the labeling directory. You can use the following command to view the text file that was created. cat labels/training.txt. Okay. Once we have our text file, it has to be converted into a TensorFlow record that can be used for training. This has already been done for you, but you can use the following command to create the dataset. AOCR dataset./labels/training.txt ./training.tf records. As mentioned before, this has already been done for you and is stored in the labels directory. We have created two datasets, one for training and one for testing. As mentioned in the introduction to machine learning task, day 14, we need to fresh data that our CNN has never seen before to test and verify that the model has been trained accurately, not overtrained. Just as in the previous dataset, to train the model and then testing dataset. Just as in the previous task, we'll only use the training dataset to train the model and then the testing dataset to test its accuracy. Training and testing the CNN. That's a heading. Training and testing the CNN. Finally, we can start training our model. This has already been done for you, but with all the preparation completed, you could be able to use this command to start the training. cd labels and AOCR train training.tf records. Training will now begin. Once the training has completed a couple of steps, stop it by pressing Ctrl+C. It tells you to stop it because it takes forever. Like, you can literally have this running for 50 minutes and it still not be done because this is a very limited like resource VM that we have access to. So seriously, don't let it run all the way. Let's take a look at one of the output lines from running the training. Okay, it says 2023 10/24 05 31 38 766 root info step 1 10.058s loss 0.002588 perplexity 1.002592. In each of these steps, the CNN is trained on all of our inputs. Similar to what was discussed in the Introduction to Machine Learning task, each image is given as an input to the CNN, which will then make a prediction on the numbers that are present in the CAPTCHA. We then provide feedback to the CNN on how accurate its predictions are. This process is performed for each image in our training dataset to complete one step of training. The output from OCR shows us how long this took to perform this round of training and provides feedback on the loss and perplexity values. Loss is the CNN's prediction that's the prediction error. The closer to value to 0, the smaller our prediction error. If you were to start training from scratch, the loss value would be incredibly high for the first couple of rounds until the network is trained. Any loss value below 0.005 would show that the network has either completed its learning process or has overtrained on the dataset. Perplexity refers to how uncertain the CNN is on its prediction. The closer the value is to 1, the more certain the CNN is that its prediction is correct. Consider how perplexed the CNN would be seeing the image for the first time. Seeing something new would be perplexing. But as the network becomes more familiar with the images, it's almost as if you can't show it anything new. Any value below 1.005 would be considered a trained or overtrained CNN. As the CNN has already been trained for you, you can now test the CNN by running AOCR test testing.tf records. Testing will now begin. Once a couple of testing steps have completed, you can stop it once again using Ctrl+C. Let's take a look at two of the lines. 2023 10/24 06 02 14 623 root info step 19 0.079 seconds accuracy 100.00% loss 0.00448 perplexity 1.00045 probability 99.73% 100% 37469 and another one that does pretty much the same thing, and I can read it all. Perplexity 1.9. Okay. As you can see from the testing time, running a single image sample through the CNN is significantly faster than training it on the entire dataset. This is one of the true advantages of neural networks. Once training has been completed, the network is usually quick to provide a prediction. As we can see from the prediction provided at the end of the lines, one of the CAPTCHA's predictions was completely correct, whereas another one was error, mistaking a 5 for a 6. If you compare the loss and perplexity values of the two samples, you will see that the CNN is uncertain about its answer. We can actually use this to our advantage when performing live predictions. We can create a discrepancy between CAPTCHA prediction accuracy and CAPTCHA submission accuracy, simply by not submitting the CAPTCHAs that we are too uncertain about. Instead, we can request a new CAPTCHA. This enables us to change the OPSEC of our attack, as the logs won't show a significant amount of entries for incorrect CAPTCHA submissions. We could even take this a step further and save the CAPTCHA images that were incorrect on submission. We can then label these manually and retrain our CNN for further improve its accuracy. This way, we can create a super capture cracking engine. You can create more about this process here. Hosting our CNN model. So this is what we would normally do if we had access to the Docker container, which for some reason we don't. This is where essentially we do take the wheel, and it's very simple. Essentially, we host the model, and then we set up the script, and then we wait. Okay, so I was wrong. Oh, it's because it's called hosting our model rather than hosting the model. That's why I couldn't find that at first. But there is a section that says hosting our model. Now that we've trained our CNN, we'll need to host the CNN model to send it CAPTCHAs through our brute forcing script. For this, we will use the... Oh, actually, what I could do is find brute forcer. Does this thing have locate? Locate.
Speed locate, root 10-locate, no pattern to search for specified.
Locate brute forcer.
/op/metasploit framework /embedded/framework /doc/metasploit framework .wiki/ how to use MSF auxiliary auth brute brute forcer.md root 10-10-32-173 /op number root 10
It's almost like we have the completely wrong... Are we in the wrong machine? Is this the attack box?
TryHackMe advent of cyber 20 TryHackMe start machine clickable play but start machine unavailable.
This is the wrong machine. Okay, that explains a whole lot of stuff.
Logout.
All right. That means we have to do the thing what we did. Okay, so I could have actually just... Okay, this explains a whole lot of things. I was already wondering why we were root. Normally we're not root on these VM machines. Okay. So why is there an AOC 2023 thing on the attack box, I wonder? Has anyone looked around that thing for a but? Okay, that's really strange.
TryHackMe advent of cyber button open in 1 hour 5 clickable OCR capture 13 clickable th clickable clickable thm attack box clickable link access desktop and 81s.
That is my bad. That is definitely my bad. I'm very sorry.
Clickable thm attack box. Clickable out 1 hour out of clickable OCR clickable thm attack box. Click 1 hour button 1 hour clickable link frame graphic out of
Let me just
link clickable
terminate.
Click 1 hour button your machine has been terminated. Button 1 hour clickable OCR clickable link access desktop and 54.
Yeah, okay, we terminated the attack box. Now we're like loading into into the right machine. That was my bad. But it'll probably be a very similar process. It might actually even be easier because we have the... We don't have to change the password this time. We just need to put our key in there, which I have ready to go. So I'll just really quickly crack this SSH again, and then we can actually do the things that we were told to do. At least we can start up the machine and then move that Docker thing across that we were about to go do. Because like, doing the training and things is not worth doing because it's already been done for us, so that's not really necessary. But getting the moving the container will be cool to see. So let me see if we can put that on the video at least. That'd be fun. We didn't lose any real time with this anyway, so I'm not super like stoked to redo the entire video because of this little goof. Just explains is how inaccessible this part of the page currently is. It's just hard to see what you're doing a lot of the time. So I'm going to just really quickly do this again. The thing that we did before. I don't think we even necessarily need speech for this bit. Let's see, terminal, there it is. Okay, we're in the terminal. We're going to run our commands. This is really, there we go. cd.ssh rm authorized keys. Nano authorized keys. Paste. Save. Yep. What is the IP I need? 10.10.140.244. Okay, does it work? It does. Excellent. Okay, so now let's scroll up a little bit really quickly to run that Docker command that we needed to run. Docker run this one. And I'll have the computer speak so we can verify that it's working this time.
D027040501F712 D27251 Sec 82 C714 D00798 DCC80.
Look at that. We got our
D0270405
thing that we were expecting to see. Very nice. We'll copy that because we need to run that execute command.
C 5 D47 C 0 B 07 A F 0 D2 space.
Yep.
D0270440.
All right, we'll do that. Docker exec command, docker exec -it paste /bin/bash from memory. Let's see if that is correct. Docker ps, yeah, blah blah. Docker exec it container attributes /bin. Yeah, that's correct. I did it right. Again, I'm going to put the thing on the screen really quickly. Yep, I see the thing. I see the Docker container. It's working. So now we go back to hosting our model, and I shall start reading. Now that we've trained our CNN, we'll need to host the CNN model to send the CAPTCHAs through our brute forcing script. For this, we will use TensorFlow serving. Once a CNN has been trained, we can export the weights of the different nodes. This allows us to recreate the trained network at any time. An export of the trained CNN has already been created for you under the /ocr/model directory. We will now export that model from the Docker container using the following command. cd/ocr and ncp-r model/tempdir. /tempdir was in that previous command that we ran. And basically what that does is the v flag and the tempdir folder makes a sort of shared folder between the Docker container and the host machine. So what this does is it literally just copies that file folder from the container to the shared space. I'm going to run that. It's doing it. It's done. Okay, very good. Once that's complete, you can exit the Docker container terminal, use the exit command, and kill it using the following command. You can reuse docker ps to get the container ID. Docker kill container ID. Okay, so we can do that. We'll exit out of this. And I'm going to just change the previous command so it says docker kill instead of docker exec it. And then we can murder this whole entire container because we don't need it anymore. And I think from this point onwards, I'm going to show the the command line window, because I'm just going to be reading the text anyway, and the action is now going to be in this window. So I'm going to do that real quick here. There it is. Wait, is this TryHackMe? Is this in Windows Terminal? I guess it is. Yeah, looks like. Oh, okay. Well, fine. Uh-oh.
Speech mode top. Ops 29. Ops 29.
Yeah, well, okay. That one, I guess. Okay. I thought we were in CMD, but sure. Yeah, we killed it. TensorFlow serving will run in a Docker container. This container will then expose an API that we can use to interface with the hosted model to send it a CAPTCHA for prediction. You can start the server container using the following command: docker run -t-rm-p8501-v/temp/data/model/exported-model:/model/e capitals model_name equals OCR. That was a whole mouthful. Let me just paste that in there. You don't really need to know why all these commands do and what they do. It's just how it works. So we're just going to run this now. What? What has happened?
Speed created blank. Usage docker run blank. See docker run. Docker run requires at least one argument. Ubuntu a try. Ubuntu a try. D-O-C-K-E-R space R-U-N space dash P space dash dash R-M space dash P space.
It says it has everything, doesn't it? Oh. Ah. What the hell?
Ubuntu a try.
Wait, I'm confused. Hang on.
Open. Paste. Docker D.
Yeah.
D. Docker run T. RMP85. Docker run T. Ubuntu try. Paste. Docker run T. Docker run requires at least one argument. C. Docker run. Help. Usage. Docker run options image command arg. Create and run. Run dialog. Type the name of a program.
Okay, it's not letting me for this time. It's really not letting me do it unless I missed a part. Oh wait. I missed one bit of the command, I guess. Oh, scheiße. Let me make super sure that you can still see this because I accidentally
Speech mode op 6 properties. Ops 20.
I've disconnected the SSH session.
Combo box notepad ++.x. Combo box Chrome. Combo box Windows Terminal.x. Ubuntu try. Combo box Chrome.x. TryHackMe AOC.
Set it back to this and then this. OBS can be very temperamental, so I'm just going to make sure that it captured it. There we go. So, this is what we're meant to be doing. There's like a TensorFlow /serving at the end of that command, apparently that I didn't see because it was a different line. So let's hope it works now. Yes, that seems more promising. All right, let's see what it does. It's running a thing. It's thinking about it. It's taking a second. Yeah, a whole bunch of outputs happening, entering the event loop. Oh, shoot. Can I not? Can I have a new tab? Yeah, I'm gonna have to make a new tab because because that is now hanging out in there and I don't want to close it. 10, 10, 140, 244. Yeah. Oops. Oh, paste. And there we are. Okay, very nice. We'll go back to where we were. At some point we're going to see a script. I'm not going to go through the entire script. It's there for people to read, but we really don't need to know what the code is. It just gets explained for us anyway. So Docker run to the second. Oh, it's really like fighting me today. Docker run. Yeah, thank you. Okay, this will start a new hosting of the OCR model that was exported from the AOCR training Docker container. We can connect to the model through the API hosted on port 8501/v1/model/OCR. Now we're finally ready to help McSkitty regain access to the HQ admin. Like, finally is right, my god. Brute forcing the admin panel. We are now ready for our brute force attack. You've been provided with the custom script that we will use. You can find the custom script and password list in the desktop in the brute forcer folder. Let's take a look at the script. Let's not. We're gonna skip past that whole bit. It essentially, basically what it does is it makes it'll explain it to you. I don't need to summarize it because someone else is already going to do that for us. Everything has been provided to us today, even the answers pretty much. Basically the script checks if it'll send the it'll do an attempt. It'll grab the image, and if the image comes back with a high enough thing, security thing, certainty thing, then it'll make the attempt, and it'll keep doing that until it gets the right password, which we already know, but that's okay. Let's dive into what this script is doing. First, we load the libraries that will be used. We'll mainly make use of Python's request library that makes the web requests on our behalf. Next, we load our password list, which will be used to brute force attacks. Right. In a loop, we will perform our brute force attack, which consists of the following steps. Make a request to the HQ admin website to get the cookie values and the CAPTCHA image. Submit a CAPTCHA image to our hosted CNN model. Determine if the prediction accuracy of the CNN model was high enough to submit the CAPTCHA attempt. Submit a brute force request to the HQ admin portal with the username, password, and CAPTCHA. Read the response from the HQ admin portal to determine what to do next. Let's run our brute force attack using the following command in a terminal window. cd thing, and cd tilde slash desktop slash brute forcer and then python 3 brute forcer.py. I'll do that to give us something fun to look at. Whoosh. Here we go. And it gives, there goes the output. That's an awful lot of output. A lot of invalid credentials zipping by here. Access granted. Username admin password. Really not gonna guess this. Is apparently the answer. Well, that's great. Let it run for a minute or two and you will regain access to the HQ admin portal. Conclusion. I hope this is the final ML task. Honestly, I'm getting a little tired of them now. In this task, we have shown how ML can be used for red teaming or purposes. We have also demonstrated how we can create custom scripts to perform tasks such as brute forcing the authentication of a web application. All we need is a spark of creativity. Well, we could have taken a pre-trained model such as a Tesseract OCR. It wouldn't have been nearly as accurate as one trained specifically for the task at hand. This is true for most ML applications. While generic models will work to some degree, it's often better to train a new model for the specific task we're tackling. Now that you've had a taste of what is possible, the sky is the limit. Now. Isn't that wonderful? That was a whole lot of reading. Let's see if we can get our our questions answers. What key process of the training a neural network is taken care of by using a CNN? I believe you'll find that is feature extraction. That's correct. Hooray. All right. What is the name of the process used in CNN to extract the features? Convolution? Convolution? Yes, that is the correct answer. Hooray. What is the name of the process used to reduce the features down? Pooling? Pooling is correct. Hooray. What off-the-shelf CNN did we use to train a CAPTCHA cracking OCR model? I believe that was called Attention OCR. That is correct. What is the password that McGreedy set on the HQ admin portal? What do we see? Really not gonna guess this. That is correct. What is the value of the flag that you receive when you successfully authenticate to the HQ admin portal? We don't know that flag. It's already filled in here, but we don't know that flag because we can't solve the captcha ourselves. So we're going to try something different. I'm gonna kill this script. Kill it.
Speech mode. Yep.
We're gonna see if we can find where that script is. I'm assuming if I know this person at all and he did his VM exactly the same as yesterday, I think I know where it might be. So let's go look and let's go hunt. Let's see what's happening in root. We are now root. Very good. Let's go see what is in /root. Oh.
Datasets key snap web app. Datasets key snap web.
Datasets key snap web app. Web app looks promising. Let's have a look in web app. What's in web app?
App.py captures
App.py captures dataset templates. App.py looks awfully flasky. So let's have a look at app.py. Super apple pie, nano apple pie, please. I would like a nano apple pie. There is our stuff. Logging. Yup, it's Flask. Okay, very good. Let's see if we can find where the problem is here. What the flag is. Data. Yeah, if your model runs on a different part. Change this. Okay. Let's see. Captcha configuration. No, we're not going to do that. Add config secret key equals UID.UID. Okay. Captcha enable equals true. Where is the flag? Yeah, this is all captcha stuff. We don't need the captcha stuff. I'm pretty sure it's gonna be in here somewhere because it's gonna be in the template somewhere as well. App route / method post. Okay, here's the index. Yeah, if request method equals post. If captcha validated. Username equals admin. Yep. Password is really not going to get this. Very not. USR equals request.forms.get username. Yep, very well. This is just a login validator. Very simple. Oh, as granted. Flag. Here it is. That wasn't very hard to find. You need to scroll to the right to see it, though. You can't really find it right now. Flag is THM left brace captcha dot can't with an apostrophe dot hold dot me dot back right brace, and all these are capitals on the first letter. So yes, we couldn't have known this was here because it's not advertised anywhere, but because I am a developer, I knew to look for this, and I did this before to do the defective toy trick as well. So because I knew this creator and how he works, or how they work, I was able to inaccessibilize this particular task. But this would not have been accessible for pretty much anybody else, so that's a problem. In any case, that's the flag. That's the final question. If you enjoyed this room, check out our red teaming learning path. We have clicked the completed button already because I was almost going to lose my streak. And with that, we have finished this task. Oh my god, this was a very long task. I'm going to cry in a corner now. This was great. I'll see you again for the next one. I hope it won't be quite this convoluted. And see what I did there. And yeah, we'll see you again for day 17 tomorrow, bright and early. Have a good day and goodbye.